Hello and welcome to this video. So in this video I'm going to talk about one of my research implementations where I have tried to work with recurrent neural network, and it's about analyzing my browsing data. So what this project going to do? This project will tell you what your percentage of usage is going to be on the very next day. That means how much you're going to use Facebook, how much you're going to use YouTube or Stack Overflow or Google or so on and so forth. Alright, so why I have chosen recurrent neural network for this problem? Because any problem that deals with timestamp can be solved efficiently with recurrent neural network. That means if you're trying to predict what your weather what weather it is going to be on the very next day, or what stock prices are going to be in the very next day, then recurrent neural network is the best solution for you. All right, and in the early stage, recurrent neural network had a massive problem actually, and that was vanishing gradient problem or vanishing gradient descent, and that was solved by LSTM, that stands for long short term memory. So I have used that in my project. All right, so I'll jump straight to the implementation now. At first, I'd like to show you how I train and predict my system. I mean, how I train and predict my model. And I'd like to tell you my browsing history data was quite unstructured, so I had to structure it in a way so that I can feed it to my neural network. Now here you have to select the number of epochs. And what is this about? This is the number of times you want to back propagate your whole network. So I tried with several numbers, and I think for now it should be all right, 253 or 250 maybe. Yeah, now you select the activation function. I'm gonna select sigmoid function, which is 1 by 1 plus e to the power z, where z is a vector. I mean the set of input values multiplied with weights. Alright, now this is the optimizer. I think for now. Alright, Adam, we'll try with something else later. So optimizer is here, you can see four kinds of algorithm. There are actually different kinds of gradient descent with different learning rates. Yeah, so okay, let's train model and try to predict some value with this. %. Yeah, a lot of optimization is going on. So it's almost done. So usage of Facebook will be 86%, 0.40, 9.91, 2.2, 1.01. Yeah, okay, so this is what my system predicts my usage is going to be in the very next day. All right, so let's try to do the same thing with less number of epochs, and let's try with some other optimizer, SGD, which stands for stochastic gradient descent. Yeah. So why should we try with different combinations? I'm gonna tell you shortly why we should try with different combinations and what actually we are looking for. Actually, we have four kinds of activation function. I have mentioned only two of them here because these two are able to predict, these two are able to work with continuous data actually, and the rest of two is actually for categorical data. So as I'm working with so many continuous data, I have decided to put this two activation function in my project. Yep. So 85, 0.39, 10, 2.38, 0.99. Pretty much similar like before. So yeah. So in the next part, we'll try to evaluate the model. I mean, there is a saying that a neural network always gets better with time. The number of time, I mean, the amount of time and the amount of data is fed to the network, the more it gets efficient. So let's see for now how my model is performing, how accurately it is predicting. Yeah. Okay. So here we can actually select one of the websites. As you saw earlier, that this system is only predicting for this 5 websites, so you can evaluate this model based on only one website at a time. So shortly, how accurate this model was in predicting Facebook usage, how accurate it was in predicting Twitter usage, YouTube, Google, and Stack Overflow. All right, so here I'm going to tell you why these different combinations are important and what's your role here. Like for Facebook, if you plot the points of Facebook in a graph, you can actually figure out the property of the data. I mean, what kind of pattern it is generating. So by analyzing that, you can select your desired combinations from here. For an example, when I plotted Facebook data in RapidMiner, I found out it was really scattered and there were so many small curves. So in dealing with so many small curves, it's better to set your optimizer as RMS prop or SGD. So I got the best result for RMS prop. Let's evaluate our model for RMS prop. So actually I am saving this graph as PDF. So as you can see, this is the model evolution for Facebook. This graph represents the real data, and this graph represents the data that has been predicted by my system, by my model. All right, so let's try to train my system for the second time. Let's see if it gets better with hyperbolic tangent function. Evaluate. See, so if you, I'm gonna make some comparison between these two figures. Oh no. So can you see the difference? So in this scenario, the predicted data was actually far behind from the actual data. But now in this case, if you analyze that, the predicted data is pretty much closer to the actual data, and the squared sum error, the sum of squared error is pretty much less for this scenario. So this is called parameter tuning. You have to figure out the property of the data for one specific feature, and then accordingly you have to select your combination. So that's why you need to know what this Adam algorithm is doing, what RMS prop is how RMS prop is working, how stochastic gradient descent is working. So if you know how they are working and what kind of data fits better with one of this kind of optimizers, then you can play around with maximum accuracy. Yeah, so let's try with YouTube. Let's see. Oops. Yeah, let's see how it works for YouTube. Yeah, and let's increase the epoch rate. Yeah, 400. That's the second most scattered data structure in my problem. All right, so actually I'd like to show you the kind of name format I have used. You can easily figure out what kind of operation I did while generating these figures. So if you look at the pattern of the name of the file, this was over Facebook. 101 was number of epochs. RMS prop was the optimizer. Sigmoid was the activation function, and 0, it's just a number. It's nothing related to the operation. So from the name you can figure out the operation, the kind of operation the dataset went through. Yeah, so let's check out YouTube. Yeah, for YouTube you can see uh, here it's pretty much less. Here it's not good, here it's not good, here it's good, in this area it's good, and in this area it's good. So this is how this is how my model is closer to the reality with time. Yeah, so thanks for watching. I'll see you in the next time. Have a nice day.